So Rob, how was the IIIF conference this year? Did you go?
Yes. Yeah, it was really good. Leeds did a wonderful job of hosting. Everything was super well organized. The presentations were, by and large on topic and not just advertisements for something slightly related, which has happened in the past, but actually about IIIF and things that were of interest to the broader community. There were some good workshops, including the IIIF 3D work and other things going on to get to 4.0. Yeah,
Right.
no, it was really good. And the weather was not terrible, which is as good as you can do for the northeast of England in June.
Yeah.
Well, we were very sorry to miss it this year. I'm going to do a mute all and then ask you to unmute yourself, Rob.
So if you're just joining us, welcome. Please take a moment, introduce yourself, maybe tell us where you're calling in from in the chat. We'll probably get started maybe about 3 minutes past the hour, so you have a little bit of time to go grab a cup of coffee or have a bio break if you need to. Hi. Oh, Anne's here. I was like, I don't see any names I recognize on the people who've come in.
You see Doug Dodds?
Oh yeah. Hi Douglas, how are you? Oh, here's Josh Hadrow. That's fun. So if you're just joining us, I'm going to say this quite a few times, you might get tired of hearing me, but welcome. We're really glad you're here. We'll probably get started in about 4 minutes. If you take a moment and introduce yourself and tell us where you're calling in from in the chat, that would be great. So if you're just joining us, welcome. We're really glad you're here. We'll probably get started in about 3 minutes. If you want to introduce yourself and tell us where you're calling in from in the chat, that would be great.
Oh, I feel like I need to restart my computer. I fucked it up.
We're probably gonna mute all of our participants, but oh, good. Sarah, I'm Hanson Parikh. I'm so glad you're here. I was just checking. I was like, who recommended this? And I was, there we are. And because you were the person who made this happen. You're like, this is a really cool presentation. And we're like, oh, we know Rob. I bet we could ask him to do this as a webinar. So thank you for suggesting that. And excited.
And thank you to everyone for coming. Almost 100 already. It's only 2 minutes past. So
we had 272 people sign up for this webinar, which is a lot. Usually only about half of you actually show up. I think everybody else, gets busy or just wants the recording. Yeah. So if you're just joining us, welcome. We're really glad you're here. If you want to take a moment and introduce yourself in the chat, tell us where you're calling in from, that would be great. We'll get started momentarily, actually. We try to wait until about 3 past, but our joining rate has slowed down a little bit, so that's good. I'm gonna move that out of the way so I can read my bio of Rob, or at least reference it. So I'm Sarah Brumfield From the Page. I'm here with Ben. We host these webinars because I know we're all curious about figuring out how AI fits into our workflows or our products or our dams. And so when we hear about something good, or we happen to see a really good presentation at a conference, we often ask people if they're willing to kind of reprise them for us. So this one was actually recommended by Sarah at University of South Dakota. She's like, oh, I just saw this really good presentation, because we're talking about AI with everyone we talk to, right? And when she forwarded it to me, I'm like, oh, we know Rob. Rob and Ben and I have worked together on IIIF things for about a decade now, I think. And we have tremendous amounts of respect for him, especially his work on the IIIF standards, the W3C standards, and particularly the web annotation one. Rob currently works at Yale across their museums, libraries, and archives on a lot of projects that are linked open data oriented. So he's the technical architect and leader for Lux, their cross collection discovery platform that uses the linked open usable data, LOUD, paradigm and technologies. He's on Yale's AI advisory board, and he's worked at the intersection of cultural heritage and information science for much of his career. So I'm going to let Rob share his screen, and how we're going to run this. So we're recording this, and we will send out the recording. If we mention any resources, we'll gather them and put them in the follow-up email as well. We're going to ask for questions to be held until the end, and then we'll take questions in the chat, and Ben and I will kind of moderate that and try to pick them in order and read them out loud. So without any further ado, Rob, please take us away.
great, thank you. Yes, it's been, it has been a decade, I think, which is impressive. IIIF has been one of the standards that has demonstrated value for the community and sustainability across, I think 15, 16 years now. So yeah, it's been wonderful to work with Ben and Sarah. And thank you for the invitation to talk to you all about what we are using AI for at Yale in terms of processing data, particularly towards improving our discovery of cultural heritage, but that of course spans across many different aspects. So first, some acknowledgements. This isn't all my work, of course. There is also work by William Mattingly on my team, particularly around the handwritten text recognition and image segmentation. Also, Nelson Rios is working on an NSF-funded project called Lightning Bug. He is in the Peabody Museum. And Michael Appleby is in the libraries, who has built some really interesting interfaces on top of handwritten text recognition that I'm going to talk about as well. So as an overview, a brief introduction. By now, everyone has heard of and been subjected to numerous hype patterns around AI, so no need to go into much detail there. But what I want to focus on, of course, particularly for this crowd, is the handwritten text recognition capabilities of large language models, what we've seen and what works and what doesn't, and how we see that being used. Then some work on metadata quality and enrichment, including an example which is very much breaking, I shouldn't say breaking, very much recent, in that we put some of this work into production last night. Then some work on user interactions that is happening around how we can use AI to improve the interaction of the experience of the user with the content in various ways, and not just as yet another chatbot that lets you talk with the painting or other similar sorts of things. And then, of course, some concerns and conclusions. So first of all, how do we at Yale think about how heritage objects, digitized or not, can interact with AI? So we had a really interesting discussion about 6 months ago now, where we looked at the sorts of things that AI can deal with, being images, text, data, and audio across the top. You give it to AI, and what can you get out? Well, you can get out images, text, data, and audio in different fashions. So what do we want to do with AI then? So the tasks there are on the left. We want to be able to transcribe the images or the text, or the audio. We want to be able to summarize the content. We want to classify it, translate it. We want to be able to generate data from it. And usefully, we want to be able to recognize entities within it, such that we can then use those entities to improve our discoverability and utility of the content. But an important factor is the predictability of the process, right? So there's been numerous studies about how hallucinations can make things go entirely off the rails. There's a new jailbreak every week or so where folks have figured out how to trick the language model into ignoring its previous instructions. So we want the processing to be reliable, right? It needs to do the same thing every time we do it. It needs to be performant. We don't want to be spending tons of CPU cycles just to do something that we could have written a simple function for. It needs to be affordable, particularly at the moment, with the threats to higher education, particularly in the US. It should be ethical, right? We want to make sure that we are not abusing data that has been illegally or unethically acquired, if at all possible. It should be explainable as to what's happening, and importantly, it should be multilingual. We can't deal with just English content. So to focus then on the image as the input, right? So the use cases that we particularly care about are transcribing handwritten or printed text from an image. So the library has some 6 million images in its digital asset management system, and we have linear miles of archives which have not been transcribed at all, essentially, many of which have not been cataloged at all. And those documents are in multiple languages, sometimes multiple languages in the same document. We want to be able to create web accessibility text for an image, right? It's a legal requirement, which we are falling short of in certain circumstances, just because of the amount of time and human effort it currently takes to generate those alt texts. So if we can get an AI to do that for us, that would be wonderful. But with IIIF, of course, you can zoom into particular areas of an image. and you might have that area of an image rendered as part of a different web page rather than only within a IIIF viewer. So we want to also then have this functionality available essentially in real time and on demand for when segments of images are requested via IIIF, and then they can also carry their alt text along with them. We want to be able to categorize images according to some vocabulary. Is this a painting? Is it a manuscript? Is it a letter? Is it a book? Segment the image into different parts to say, you know, here is the person in this image, or here is the cat, here is the hat, here is the dog, etc., etc. And then use those segments for some purpose, again, probably via IIIF, to extract them from their wider content. And finally, we want to be able to extract or create data from the image. And this is one of our primary concerns. So then to look in particular at handwritten text recognition, we have done quite a lot of effort, put in quite a lot of effort over the last, say, 5 months to make our pipeline reasonably robust and reasonably accurate at a reasonable cost. So the primary then driver for us is activating the content that we have in the archives for discovery and for other purposes. Right? In particular, the archival content can be about something else which is in our collections. So we of course have provenance files in the archives that are about the paintings or specimens in our museums. So we want to then accelerate our provenance research by automatically extracting the text from those artwork specific files to then be able to, you know, not have to rely on humans to transcribe all of the words and then find the right person who speaks the particular language to be able to transcribe and translate the information. We want to find ethically problematic content. For example, the Yale Peabody Museum has had a history of collecting human remains in the late 19th century. So we want to find all of our letters that are about those human remains to make sure that all of them have been properly repatriated and are being treated in a responsible and ethical way. We're looking towards being able to automate the cataloging of objects in this way. For example, we've worked through about 12,000 stock bond certificates for a numismatics collection in the art gallery. And the Peabody is looking at reading insect labels, of which we have millions, in order to then get the collector and where they collected the specimen and so forth. So let's look at some examples. So here is, and if it looks slightly pixelated, that is intentional. It really is slightly pixelated. Here's an image of a receipt. It's in French from Henri Matisse for 4 paintings. So this is in our provenance file for one of those paintings that we saw. And we gave it to Gemini 2.5, so this is Google's large language model, and asked it, please transcribe, carefully transcribe, line by line, and that's an important hint for folks doing this, that line by line really helps the LLMs to focus. Please transcribe line by line this image, and didn't give it any other information, just transcribe it line by line. And with 2 errors, neither of which really makes much difference, it got every single character correct. Right? So Henri Matisse, bonjour, monsieur. So yes, you can see LL, S, it should be SS, monsieur. J and G, but could just be a fancy J. So that's the other error. Bernard Jeune, personal nom, blah, 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 blah. Right? So given that it did this receipt pretty well, we thought, you know, this is worth exploring. This was sort of our first test case. So we looked at, can we use this technique at scale without costing more than it would take to just pay someone to go through and transcribe all of the content. So in the archive of O.C. Marsh, the famous paleontologist who worked at Yale, there are some 22,000 letters which we needed to transcribe to find those references to human remains. So we tried various models and then looked at the on a small sample, and then looked at how much it would cost to do the whole lot and what the quality was. So with Transkribus, it was going to cost quite a lot to do it, and the quality really didn't match up to the expectations that we had initially going in. We also looked at Nova Pro and GPT-4o. Nova Pro is one of Amazon's sort of own LLMs that you can get via Bedrock. We did a few experiments and the quality was really not good. So we didn't calculate even how much it was going to cost. GPT-4o, of course, now at this point is a bit outdated, and the newer models do a better job. And even 4o did an okay job, but it was going to cost us quite a lot. DeepSeek spent a lot of time thinking about it, so it would have taken a long time, but the quality was okay, approximately the same as GPT-4o. However, the ones that we looked at in significantly more detail were the two Qwen vision language models, Qwen 2 VL and Qwen 2.5 VL, both of which are totally free. You can run them in your own environment, and the quality was good. However, for the ease, the sweet spot, at least at the time, was Gemini Pro 2.0. So we ran all 22,000 letters, and it cost us about $40 to get really good results. We also ran it with Flash, and it got good results, approximately the same as 2.5 VL. And we used Claude Sonnet 3.5. That costs a lot more, right? 150, almost 4 times as much as Gemini Pro. It found a few mistakes that Gemini Pro made, but the sweet spot, at least for us in terms of what we wanted to use it for, which was, note, to find mentions of human remains, not to create digital editions, was around the sort of $40 mark for the 22,000 letters. So here's an example of what it does, right? So the only mistake it made with this particular letter was, and it makes no difference to the sense, it sees here, this sort of squiggle here is full, is general, but it sees it as an abbreviation of GENL. So in terms of the language model side of things, right, it's an acceptable, it's a probable word that would appear here because it is just the abbreviation for general, and indeed it is general in the text. And every other word was correct. So we were happy with that level of accuracy. So we then took the same approach and applied it to some stop bonds. But here we wanted to not just extract the text, but we wanted to then do some post-processing as well to, for example, find what color is it, because the color of the stop bonds makes a difference. Extract the company name from the text, how many shares is it, and so on. Right? So this is sort of towards the automated cataloging of the stop bonds, and this work was completed, and the donor who gave us the stop bonds saw it and was astounded that we could do it so quickly, because we had previously said, well, it's probably going to take us a year to get through all of these stop bonds and in terms of cataloging, whereas using AI, we could do it overnight, and it cost us $7.40 in terms of the processing in Gemini Pro. So that, yeah, literally cut years of work off of our plates. The really big one which I saw Deb, hi Deb, doubtless knows about, is that we have some 4 or 5 million insect specimens in the Peabody Museum of Natural History, and only about 300,000 of them are actually catalogued. And we have students that come in and help catalog them every year. But if we could digitize them and then extract the information off of the labels that are on the pin, then we would be able to very, very quickly get through that collection. So we have a 3D digitization setup that produces a very detailed 3D model by a process called COPIS, which is computer operated photogrammetric imaging system, which then gives you something like this. From that 3D model, we can then extract the labels. So here's the label, and this is digitized, taken off the pin and digitized, but this is the sort of thing that will be on the label. And then from that, we can extract, where was it found, 136 degrees east, 4 degrees south, which is here in Papua New Guinea. This is work that is funded still, thankfully, by the National Science Foundation. So the way that it works, then we get lots of different images of the labels. And then using AI, we can compute what those labels would look like. And here is the pin. You can see the shadow of the pin. So the system computes what the label would look like from all of the different images. And from there, we can use the same handwritten and printed text recognition to extract the data and process it to do the cataloging. So yeah, we believe that this sort of process will be able to accelerate our cataloging of the collections by many, many times. One of the other areas that really dramatically impacts discovery, though, is the quality of the metadata. If there are errors in the metadata that prevent it from being connected across collections or across objects, then you won't be able to find it. Equally, that we want to be able to enrich records that don't have as much information available about them so that they are easier to find. So I won't spend too much time on this, but some examples of where this comes in handy. So in our library collection, in the MARC records, we have a lot of place records. And because of the way that we have acquired all of our MARC records, there are errors in the way that the places are represented when they're part of subject headings. So there's a rule of, is it Chicago, Illinois, or Illinois, Chicago? But sometimes that goes wrong, and you end up with things going horribly wrong with circular entries and so on. Equally, there are times just when there is a place that has the same name as something else. So there is an Italy in Yates County, and the system has put Italy, the country, into Italy, Yates County, and all of a sudden our hierarchy gets broken. So thankfully, language models are pretty good with the sort of their basic background knowledge to be able to say, is the country Italy part of Yates County in New York? And it will correctly and confidently say, no, it's not. Don't be stupid. Equally, because of the cataloging again, there are places that aren't actually places. So it's tagged as being a place in the MARC record, but because no one has actually used those specific subfields before, then probably was it Piedmont ethnic relations got the geographic subtag just by mistake because it was next to a place. So by the rules, it says, okay, ethnic relations is a child of this place. So again, AI and language models can easily tell you that there is no such place, ethnic relations, in Piedmont, Italy. So that's some sort of QA level stuff, right? We can see, find errors using language models. But equally, at the same time, once we are processing the places, we can say, okay, and give us a description. Right? So this was a place in France that was just the name because it came from one of these subject headings. So by then feeding the AI, here is all of the texts about it. It's in France. Here is the name. The AI can generate a descriptive note, which then makes it much easier to find. Because if you were searching for, Basilica of Notre Dame de Liesse, or it's in the particular department or the area, then it will show up. Whereas previously you had to search for exactly LIESSE in order for it to match this particular place. And then finally, again, because of cataloging practices and the scale of the records over time, there are clearly typos in the subject headings, a missing parenthesis here, the full name repeated, and so on, which we can use language models to then detect, these people really are the same person. So the way that we have done this is to use a language model to parse all of the names of all of the people out into first name, middle names, middle initials, last names, dates, epithets, suffix, prefix, role, etc., to then run an algorithm across all of those parsed names to predict the likelihood that Tolkien, J.R.R., John Ronald Reuel, 1892 to 1973, really is the same person as J.R.R. Tolkien, 1892 to 1973, because he has the same first name, same initials, same last name, and same dates. Even if there's some other stuff going on here, all of these would match into J.R.R. Tolkien, not into Christopher Tolkien. So this is what we just put into our sandbox, and it, for example, cleaned up around 15 labels, typoed labels for Lenin, and said, all of these are really Lenin, into that one record, which I can show you in a bit. So that's this. We hope that this will be able to clean up some of the errors in the graph that mean that Tolkien or Lenin or whoever else have multiple entries, because previously we couldn't say that these records were really all the same person. So then user interactions is the last section, but is a reasonable one. So once we've got the text transcribed of handwritten documents, we then want to be able to do stuff with that text. Right? So here is an example of what we could do. So here is one of the letters from in the Benjamin Solomon archive. It's in English, handwritten, and there's notes: open the collections AI tool in a new window. So if you click that, then it takes you to an interface whereby it goes off and does the on the fly at the moment handwritten text recognition on all of the images within that particular object. So it could be by object, I mean, it could be just one letter, or it could be an entire folder, depending on how it was cataloged and digitized. Then, instead of showing the text directly, because it could be wrong, and it's not a digital edition interface, it's a research one. We then have some sort of pre-configured prompts to say, provide a summary of the text, or list the dates, list the events, the places, the works, medical terms, money and finance, and so on and so forth. So then you can say, just click on provide a summary of the text. It feeds that back to the AI, along with all of the images. In this case, there are 59 of them, and summarizes, the text is a collection of letters and documents related to the American Journal of Science, Yale College, various scientific and academic matters, from the mid-19th century, blah, blah, blah. Or mentions of money and finance, right? The subscription terms for the American Journal of Science was $5 per annum. If only that were the case today, then our financial woes would all be solved. So yeah, we think that this is an interesting interface because it's not a chatbot, but it gives you sort of some pre-configured chats to ask of the system. It doesn't show the text, so if there are errors in it, and if you run it on a cheap model, then there often are significant errors. But the summaries and many of the X's all work reasonably well. So we've been pretty pleased with that. So then what about chatbots? Well, from my perspective, the world does not need yet another chatbot. The interaction with chatbots, from my perspective, is that it's not transparent as to when the chatbot is being overly confident, but with no real basis for that confidence, or where it's getting information from. So that is improving with tool use and references and so on for the deep research modes and so on. However, if you just say, tell me about this person, then the chances are pretty likely that it's just going to make up something which you don't want to trust, and you have no real way to be able to verify that what it's saying is correct. So it gives you then a fake sense of certainty, and if folks in leadership positions then believe that certainty, there is significant challenges ahead. And then finally, the user doesn't necessarily want a summary of a whole bunch of stuff. Right? Perhaps they want to just do a search and find the things and do their own research. So there is a good side to chatbots, however, which is that they've acclimatized users to an ongoing interaction, with the emphasis on interaction rather than just doing a search and it didn't work, so they go back to the front page and they do another search. It still didn't really work, so they go back and do another search, another search, another search, right? So chatbots have helped users to sort of think through refining what they want rather than trying again from scratch over and over again. So that we can leverage at the very least. So the search ecosystem then that we are in is, I think, along these lines. So in our libraries and museums and archives, we have curators, catalogers, and archivists who understand their collections. Right? And they can interact with a database, which is managed and built by some developers. They've also probably got some export of that information that describes the object. Then over the network, a web application, probably written in JavaScript, certainly by someone else, interacts with that information and presents an interface on a screen to the user who has a question. Right? So in this scenario, the optimal way for the user to get an answer to their question would be just to talk to the curator. Right? You skip over all of this technology garbage and just go and talk to the person who actually understands it, explain what they want, and hear the answer. Right? Of course, this doesn't scale. Right? Not everyone can come to New Haven, and we don't have an army of curators at the beck and call of users to answer all of the questions that folks might have about our collections. So what we have today is technology mediated telephone. Right? So the user tries to interact with the web application that then works essentially with the understanding of the developer as exemplified by their code, which then also works with this export of the data from the system. And then you've got another telephone translation problem, which then is mediated by these people who have to create it and interact with the database, which probably is built by a vendor and not actually understood all that well by these people. And then the actual folks who understand the object have to deal with a different interface to the vendor provided collection management system to be able to do their cataloging. So it's no wonder that our systems do not provide a good experience, and we've had many decades worth of interoperability woes because each step along the way introduces a chance or even the likelihood of miscommunication. So even if there was perfect data here, by the time it's gone through all these translations, the user still doesn't get any significant benefit from more work happening here. So how can we use AI to improve this? We could skip over much of this effort by instead having the user interact with an AI, not to provide the answer, but to say, say the question is about part of the particular painting, right? The AI doesn't give the answer. The AI will help the user to formulate the question such that it reduces or limits the amount of mistranslation that happens along the way, right? So we're not looking to replace curators, we're looking to improve the interaction. So we've put this into a, not production yet, but we've certainly hammered on a demo prototype system quite hard in Lux. So Lux is our cross-collection discovery environment. It has about 40 million records, about in linked data terms, it's about 3 billion triples. That provides unified access across all of the collections at Yale. So you can, for example, do questions, ask the AI questions like, I want photographs with a digital image of hats, and you get the 105 objects that are photographs and show people wearing hats and have a digital image. So how does it do that? Right? The system doesn't interpret this, the AI does, and the AI then generates the right graph query or advanced search in Lux to be able to do the search. So looking for objects that have all of the following features. They're categorized as a concept called photograph, they have a digital image, and they include a work, or show an image in this case, that's about a concept that's called hat. Right? So then you can do this for all sorts of queries. If we have time, I can show you some, such as just putting in a keyword. It will say things like, do you want, you searched for Trumbull, did you mean Trumbull the place or Trumbull the person? Or complex graph queries like, I want prints showing flowers that were created by a woman from Barbados. And it will find the 15 prints spread across our 2 art galleries that match that query. However, there is another step that we can do, which is we now know that from the metadata that there are hats in these images. So we could give the images to a segmentation model such as YOLO or YOLO-E, and say, find me the hat in this image. So we did some experiments with this, and it's pretty good, not quite ready even for prototyping yet in terms of demos, but the likelihood of finding common objects from the queries is pretty good. So you could imagine a environment in which not only do you use the AI to do the translation of the search, but also to then pick out the search terms in the images and say, here is the hat, here is the hat, here is the hat. And interestingly, it didn't find it in a hat in this image. I think it's very hard to see, but I think it's the sort of bonnet of the person on the left that meant that there is hat in the metadata, but the AI doesn't think it's a hat. And whether a bonnet is a hat, yeah, I leave that up to metadata specialists to argue about. So concerns and conclusions, and then we can have some discussion. There are, of course, a bunch of concerns about using AI for sensitive topics in cultural heritage. There is the ever-present concern about reinforcing the bias. So language models are primarily trained on the web, which is modern and it's English, North American English even. So by relying on the models, models trained primarily on that content, we will get a very definite bias. There's a ever-present concern, especially at the moment, around the total cost of ownership, including the environmental cost of using these models. How much will it cost in the future? At the moment, we know, of course, that OpenAI and likely Google and the other big providers are losing money hand over fist because they're not charging the users, what it actually costs them as a sustainable model. They're trying to win the market share struggle by providing as much value as cheaply as they possibly can for as long as they can, until they essentially run out of money and disappear. So once we are actually paying how much it really costs, will it still be affordable? At the moment, we're in this sort of AI bubble, but it's going to burst sooner rather than later. It is difficult to detect errors. The AI generated content is always presented very confidently, and it has no real way to give accurate probabilities about its own accuracy. And the reliance on AI can lead to complacency across the board in engineers and leadership and users, and this lack of thoughtful engagement rather than just, well, we'll ask the AI. We'll see how that goes. However, it is here, it works, and as I think we've seen with the handwritten text recognition experiments, it's affordable. So it can accelerate workflows pretty dramatically. We've saved years of effort essentially by running an AI overnight, but it's not a silver bullet. There is things that it really cannot do. One thing that we tried earlier that works now but didn't at the time was to use rulers, which are in the image, to say how big is the object in this picture. And because at the time the AIs had no notion of what a pixel was, it couldn't use the information from the ruler to then measure the object because it had already expanded it into a semantic space rather than pixel by pixel. However, by feeding or by using standards, we can easily feed knowledge to the AI to improve its accuracy and to improve our own workflows and pipelines because everything can be optimized. So for example, AIs that use or can process images don't actually use all of the pixels. So using IIIF, for example, we can get the right sized image or the right amount of color, the right region. We can extract, here is the text of the image rather than here is the entire image to get a better result. We can use standards for data processing and improving the knowledge graph. It can improve the end user experience, as we've seen, and it improves the overall accuracy and capabilities of the discovery system by finding and, in some situations, correcting errors in the original data. So basically, at this point, at least our perspective is that we need to understand when and how to best use AI for our cultural heritage needs rather than if we should use AI. So that is the end of that. Thank you so much for your attention. And stop sharing.
Yeah. Yeah, we don't see your slides anymore. So.
Great.
Thank you so much, Rob. That was super fascinating, and your results are kind of blew me away. We have questions in the chat, and I love this. Josh Hadrow has the $1 million question. What are the prompts or scripts you're using to tease out in his case, subject heading errors, but I would say any of these.
Yeah. So yes, some of the prompts that we've been using are in GitHub repos, which I can put a link into the chat in a little bit. Particularly for the query translation ones, because they're quite long. For the place ones, the prompt was really simple, actually. It was essentially, here are two places, name. Here is the information about those places from the graph. Is place A part of place B, or is place B part of place A? And then please answer with, in a structured form. And because the language models have seen those place names so many times, it did a almost perfect job of predicting, certainly from the samples that we ran. So we didn't really do much chaining. I think there was maybe 2 or 3 in a row to get to the full answer, the full set of answers, such as, once it had said, Chicago is part of Illinois, we would then say, okay, please give us a 1-sentence factual, neutrally written description of Illinois, Chicago, or Chicago, Illinois. So yeah, which we then put into the records. So some chaining, certainly it wasn't tool use, it wasn't MCP or any of the more modern agentic approaches. 2 reasons for that: 1, they weren't available at the time, and 2, they're very expensive. The tools can expand the context window astronomically. You only have to run an open-ended question once, and you've used up all of your tokens for the day. So yeah, it was mostly some carefully written code that ran through the data set and said, please tell us if this place is part of that place, and please give us a description. For the names of people, we produced a structure in Pydantic for JSON to say, here is the structure of a name, here are all the fields, this is what all the fields mean, here is a name, please parse this name out into these fields. And just did that on all 4 million people in the system, which, yeah, ran over a day and cost us about $70 or so using Flash. So it's really affordable. It's it's quick enough that you don't need to worry too much about it. It doesn't take months. And yeah, and the results have been very accurate.
Right.
Are they model dependent? It's pretty much plug and play from our experience. We did a little bit of testing, particularly between the major vendors. So some prompts work better in the OpenAI, the ChatGPT models compared to Gemini, compared to the Anthropic models. But it wasn't there wasn't a lot of model specific engineering that we had to do. The normal structures of, what is the goal? Who are you? What is the goal? What is the background? What's the structure of the answer? And here is the question, seems to work pretty well for all of the models.
I'm going to insert a question I have that's not in our list, but how did you measure quality of your output?
That's exactly my
That was your question
yes.
too, yeah.
Yes, that is the $1 million question.
Yeah.
So we did quite a lot of just eyeballing the results, of working through, here is the top 100, or here is a random 100, how many are wrong? For the transcription of the letters, which I think is probably the most interesting set of work that we've done for this group, we used a genetic algorithm, so not an algorithm from the genetic gene sequencing domain, as opposed to a genetic AI algorithm, whereby it can very quickly find overlaps, right? So if you have lots and lots of G's and C's and A's and T's, and you want to find patterns that have moved around, then, and you've got the human genome, you need to have very, very, very fast algorithms to do that. So we used that algorithm to compare the output from all of the different models that we ran across the same image, and then computed how similar are the different models. And if they're all very similar, right, then it's very likely that they all read the same words because those are the words, right? So that gave us a curve, which was basically, you know, a power curve. You know, after the bottom 10% was garbage, and then 90%, sorry, the bottom 10% was garbage. Then there was about 85% that was good enough for all of our purposes, and then the top 10% was absolutely perfect across all of them. So that doesn't say that even the 100% ones are correct. It just says that all of the models, you know, produced exactly the same output. So, however, you know, if they're producing, you know, 90% the same across 3 different, you know, very different models, so Anthropic, ChatGPT, and Gemini, and it's 90% plus the same, then chances are it really is 90% accurate rather than that. Well, and that's the lowest bound, right? Probably there are some, you know, words that they just read differently, but if you average out, then, you know, between them, if each model got, you know, a different word wrong, right, then each model is actually 96% accurate rather than 90%. So it's the lowest bound would be 90. So that was, for us, that was like, all right, this is good enough for us to process, because again, we're using the information to generate further information rather than it being the endpoint of a digital edition or anything like that.
Okay, next question. Can you elaborate on how images and tagging work, particularly features like batch image uploading and tagging using a controlled vocabulary?
Yeah. So we didn't really do much tagging, sort of, you know, what is in this image. We did some of that with, working on some of that with the alt text generation. And we have some examples, thank you to a former colleague at the Institute for the Preservation of Cultural Heritage, where the AIs all did very badly. So those are kind of our nasty cases where it's a black and white photograph and it's 90 degrees rotated, and you ask, and it's as part of a larger image, and you're asking about the rotated black and white photograph. So for the alt text generation situation, we then essentially just do human in the loop to say, you know, is this alt text good or not? But yeah, we don't really do tagging unless you mean the hat example. So the hat case is a model called YOLO-E, which is an image segmentation algorithm. It's on Hugging Face, it's free. And you can just say, you know, find all of, you know, tag all of the things that you can see in this, and you'll get many different bounding boxes or polygons. But you can also say, you know, find the hat, and it will find the hat. It doesn't work for it will find cats, it will find dogs, it will find hats, it will find people, tables. It won't say, you know, this is a picture of Ben, right? It will just say person. So it's not good for cataloging, but it is good if you've got a cataloged record and you say, right, where's the person? Or, you know, how many people have glasses, right? 3. Ben, Sarah, and Rob all have glasses, right? But it's not a cataloging tool. It also doesn't use controlled vocabularies. It was just, at the moment, it was just the segmentation model from Hugging Face that we were using. Then Josh asks about UX. So we have not done any serious UX work yet. However, we're about to embark on it with a wonderful postdoc in the library, Chelsea Fitzgerald, who along with Mike Appleby and John Manton, wave John, hi, are looking at how we can use, what are the impacts on users of the library system with interacting with some of these tools. So we don't have any results yet, but we're about to start work on it.
Well, we'd like to skip down to a very popular question.
Not to mention it,
Mike
where we're thinking.
Yeah, like you showed, so many of these models are around 95% or so accurate. Have you seen good interfaces for letting experts or volunteers fix those 5% or so inaccuracies, or point them to the items that need connecting the most?
Correcting
The most.
Yeah. Hi, Mike. So it would be wrong of me to not first say, well, there is from the page, right? So, which is a lovely interface, and, it does an excellent job of being able to correct the data and so on. We've also looked at eScriptorium as another tool for the custom output, so for the stock certificates. We built our own little data correction tool that shows the image, shows the text, shows the extracted JSON, in a pretty form, and then the user can just click a button to say yes, it's right, or no, it's not right, and fix it. And
we're actually speccing out a project right now, so this is all start brave new world, but you take in input from 2 different models for a whole set of a collection. You identify the ones that are most different in those models, surface those to a human to review, maybe the top 10% or something. And then we're kind of hoping we can stop after 1 or 2% and see which model the human seems to be agreeing with, and maybe you can just waterfall that down. We don't know yet, but that's where our thinking is going, and we're hoping to start providing interfaces for that.
Yeah, that's essentially what we also were doing, using the genetic-based algorithm, but yeah, using the algorithm to try to say which one is the best. But yeah, as also to Mike's question, do we have a way to identify the bad 5%? I mean, not accurately. Otherwise, we would just solve that bad 5%.
Right. Okay, there's another great question. Are you thinking about AI visibility? Where, when, how to make AI involvement visible to users? Which I think is an awesome question. Yes.
So it's when the user is interacting directly, or either just by reading or whatever, with AI generated content, then it's easy, right? You can just say, this content was generated by model, blah, 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 blah. However, when the change that the AI has made is at the metadata level, either by merging records together that should be merged, or splitting them up, or correcting, Illinois is part of Chicago, right? There's no text, there's no content that was generated that the user is seeing. They're just seeing the results of what the AI did. And sometimes, of course, the AI gets it wrong, right? It's like, is Christchurch part of Canterbury, which is correct in New Zealand and not correct in England. So you need to know which Christchurch and which Canterbury you are talking about. So Canterbury is a region in New Zealand, but a city in England. So yes, if we were to just believe it, then the user would be interacting with an AI generated fact that really is just wrong. But we have no way to present that to the user. And we don't want to maintain the data provenance for every single assertion in our 3 billion triple data set, because then it would be a 30 billion triple data set, and we would not be able to do anything with it. So yeah, no, it's a great question. I think as much as possible, but not at the expense of breaking the whole system so that it's useless to everyone.
Anything else? I've kind of gotten lost in where we are in all of our
There's
questions.
a question, Roger asked, you mentioned running some models locally. Could you elaborate on what setup you've used for that? I think this is something that many of us are very interested in.
Especially like
does it require the use of GPUs or other intensive computing resources?
Yeah. So yes, so the models that we have run locally have been in the 14 billion range. So the sort of 8 gigabyte models or smaller, particularly ones that have been adapted to run on the Apple hardware rather than on NVIDIA, because we have Mac laptops with the integrated metal video cards. So we've done that. We've done some NVIDIA testing on, you know, a sort of $3,000 or $4,000 machine. We have not done anything at scale. So we haven't done training or fine tuning locally. At Yale, we do have, as of yesterday, access to a GPU cluster of some 80 GPUs, 80 big, you know, H200s. So we could do fine tuning or testing or training completely if we had enough time. However, we don't want to, because 2 reasons. One, it's not scalable for the sorts of things we want to be able to do, and it's not reusable by anyone else, right? So if we can make what we've done more easily reproducible just by saying, oh, here are the prompts, here are the models, put in your Google API key here and run this code and you'll get the results, so much the better, rather than, oh, and, you know, set up your own cluster of H200s that you can't buy because there's a waiting list for 6 months. Yeah, so much the better. So yeah, it's been the smaller ones, and for sort of changes around the edges of the work, of you know, write a description, given enough information that all it needs to do is summarize it, easy. Right? If it's parsing out medieval French from a scratchy microfilm image, no. Yeah, we want to use a much bigger, more capable model than one we can run locally for that.
Right. I think we're going to wrap up. I know we probably could all go for another hour asking Rob questions, but we want to respect his time. We will be sending out this recording probably tomorrow, maybe Monday. And I'll bug Rob to get a link to the GitHub repo and any other prompt resources. There's a lot of questions in the chat about getting prompt information to help us with our projects. So
yeah, thanks again, Rob. We really appreciate it.
So appreciate
it. Thank you. And yeah, thank you everyone for coming. I hope it was interesting.
Definitely.
Thank you.
Thanks.